so we've done some stuff with power in an earlier lecture, and we did a quick introduction to the idea that power was a rate of how fast energy was used. So we're going to do kind of, I think, a simple fun lab, and we're going to let you figure out how many horsepower you are. So here's the process. We're going to have you and a flight of stairs, and we're going to have you climb the flight of stairs as quickly as you can. Now, if you don't want to, or you feel like you're going to face plant, you can just walk them because we can still figure out your power if you do that. Some people like to turn this into a competition, but we'll see. All right, so I'm just going to take the example of a 50 kilogram person climbing a flight of stairs that's 10 meters tall. Now, a 50 kilogram person is about 110 pounds. So one thing I'll have you guys do is I'll have you estimate your weight in pounds, convert it to kilograms, but we're going to use this for about a 110 pound person climbing a 10 meter flight of stairs. Now, I don't think our stairs are 30 feet tall, but anyway, you're going to get the idea. And we're going to do a little ignoring of something right here, which is the fact that the person's actually going to be going forwards a little bit, and we're not going to count that in. We're just going to use the idea that their weight is the force they're going to have to work against, and they're going to have to move that force vertically to get to the top of the stairs. So their force times distance for their work is going to be their weight times 10 meters. So let's just go ahead and go through this. So first of all, if I want to know the power, I need to know how much work you're doing and how much time it's going to take. All right, so let's go ahead and go through this. What force would the person have to do to get to the top of those stairs? Well, it's going to be their weight. All right, so in physics, force is equal to mass times acceleration, or we could say weight is equal to mass times gravity. Now we're going to do some more of this stuff later this year, but if your mass was 50 kilograms, and I'm going to just estimate for purposes of the example, gravity is working against you at the rate of 10 meters per second squared. That's 500 kilogram meters per second squared, or 500 newtons. Okay? So you have a weight of 500 newtons, and your work that you're going to do is going to be force times distance. Well, if you're 500 newtons, you're going to have to get your body lifted up those stairs. So you're going to have to lift your 500 newtons a distance of 10 meters. So 500 times 10 is going to be 5,000 Newton meters, or 5,000 joules. So in order to get your body, your 110 pound or 50 kilogram body, up this flight of stairs is going to take 5,000 joules of energy. Okay? So let's say that we put the stopwatch on you and time you, and this takes you not that long, maybe 7 seconds. A brisk walk, but you're not sprinting or anything like that. Let's go ahead and calculate that. Power equals work divided by time. If you did 5,000 joules in 7 seconds, that would be 714.2. 714.3 joules per second, or 714.3 watts. Okay? If you remember from earlier, we did a calculation and we said that 1 horsepower was 746 watts. So let's go ahead and convert that. 714.3 watts times 1 horsepower for every 746 watts. And you can tell you're going to be just under that. So divided by 746, you're going to be 0.96 horsepower. All right, so that's the calculation. The question is that a realistic number? Are you actually as powerful as a horse. All right? You're probably not as powerful as a horse, okay? And a horsepower is sort of an arbitrary unit, but you also have to remember that whatever energy that you were putting it out, a horse is a much larger animal and can do that over a sustained period of time. It's probably doubtful that you could climb a flight of stairs at that rate all day long or even for an hour. You'd have to be in fantastic shape to do that. So just the fact that your power output is called a horsepower doesn't mean you're as powerful as a horse. But that's a quick way to measure how fast your power is being done in that lab.